So we are going to continue with quadratics, and so let's start with the discriminant. What is a discriminant? The discriminant is the expression that is under a square root in the quadratic formula. The discriminant is an expression that is under a root in the quadratic formula. So this is our quadratic formula. So this expression of b squared minus 4ac is what we call the discriminant. So if you have it positive, it means you can solve that quadratic equation. For example, if I have a quadratic equation which is x squared minus 4x plus 3, the a is 1, the b is negative 4, and the c is 3. So if I'm to substitute in the discriminant, I'll end up having minus 4 squared minus 4 times a, which is 1, times a 3. So I end up having 16 minus 12, which gives me 4. So if the discriminant is positive, if it is greater than 0, it means that quadratic equation can be solved to give us two solutions. Then, if the discriminant is equal to 0, what happens? We shall see that if a discriminant is equal to 0, we shall find that this equation, that quadratic graph or that quadratic equation, can only give you one solution. So meaning when you solve it, you will only get one solution. So that one solution, we call it a repeated root, meaning your quadratic graph is crossing the x-axis once. So for example, if you have x squared minus 4x plus 4, let's first see this, let's first observe the discriminant, which is b squared minus 4ac. The b is negative 4, so negative 4 squared minus 4 times 1 times ac, which is 4, so we end up having 16 minus 16 equaling to 0. When you solve this quadratic equation, you will have one solution. It will only bring x equaling 2. If you were to work it out on a calculator. So it means that when you solve it, if you're to sketch it, your graph will be just like that. That's why we say that if the discriminant is equal to 0, you only get two repeated roots. If your solution is 2, it means also another one is 2. So when you try solving this quadratic equation, it only brings one, you only get one x. But if it is positive, you get two values of x. Then let's also see if at all it is negative, what happens. If the discriminant is negative, it means that that quadratic equation cannot be solved. Because imagine taking the root of a negative, you end up having a math error. Or when you work it out on a calculator, you will see an I, which means an imaginary root, meaning your quadratic graph cannot cross the x-axis, meaning it has no solutions. So if I have, for example, x squared plus x plus 1 equaling to 0, if I'm to substitute in our discriminant expression, I'll end up having b, which is 1 squared minus 4 times 1 times 1. I end up having 1 minus 4, which is negative 3. So when you solve this quadratic equation, you'll get I. Or it is not solvable, you'll get a math error. So this issue of discriminant is very important. It is very important. So if you have it positive, if you have the discriminant, if the expression under a root is positive after substituting, This is a quadratic equation you will solve and get two solutions. If it is equal to 0, this is if the discriminant is equal to 0, this is when you get one solution, meaning your quadratic graph crosses the x-axis once. Then if it is less than 0, this is when you find that you have no roots. Your quadratic equation is not solvable. So it is important for you to remember those three cases. Case 1, where you have it positive, meaning it is greater than 0, where you have it equaling to 0, and where you have it negative. So those cases are very important, and we use those cases only on a quadratic equation. So if you have it positive, it means you will have two solutions. Okay? It means your quadratic graph will cross the x-axis twice. If it is a minimum or maximum, it will cross twice. If you have it equaling to 0, this is when the discriminant is greater than 0. If you have it equaling to 0, this is where you find that your graph is touching the x-axis once. If you have it less than 0, it means if this is my x-axis, it does not cross the x-axis. It is either like that, so you have no solution. So you need to be very careful, and when it comes to working out solutions, it is very easy. So we only use the discriminant only on a quadratic equation. So let's work out this question. What does it say? It says, find the values of k for which our quadratic equation equaling to kx squared has no real solution. So you must remember the discriminant for no real solution. If we have no real solution, it means that we shall use the discriminant of b squared minus 4ac less than 0. So before we use this discriminant, we need to first see, remember we use the discriminant on a quadratic equation. This is not quadratic, because a quadratic equation I should only have, it should be equal to 0, and I must have only one x squared. So I take this the left side, so I'll have 2x squared minus kx squared plus 8x minus 5 equaling to 0. Still, this is not quadratic because I have 2x squared, so I factorize out the x squared, and we end up having that kind of expression. So when I reach here, this is something quadratic where this is a and this is b, and what does not have an x is my c. So I bring in the idea of a discriminant and say b squared minus 4ac is less than 0. So the b is 8, so I'll say 8 squared minus 4. The a is 2 minus k, and the c is negative 5 is less than 0. So 8 squared, that is 64. I'll end up having 4 times 5, which is 20, 20 times 2, which is 40. So plus 40. Then I'll also end up having minus 20k. So you open. Less than 0. So when you reach here, we shall end up having minus 20k is less than, take everything the other side, we shall have 104. So if you have 104, so we are going to divide both sides by, negative 20, and continue and work it out, and then get your values of k, the range of values of k, So we shall have our k. Remember when you divide by, remember when you check this the other side to become also a negative. So we shall have k. When you divide by negative, the sign changes, 5.2. So this is how it is worked out. First of all, you make sure that you form something quadratic. After forming something quadratic, you bring in the idea of a discriminant. So the discriminant for no real roots is basically that. B squared minus 4ac less than 0. Okay, we good. We can use the discriminant in intersections of lines and curves. If the line intersects the curve twice, it means we shall solve and have two solutions. So if we can solve and get 2 points of intersection, then we can use the discriminant of greater than 0. Then if you have the line being a tangent, we say b squared minus 4ac is equal to 0 because we only solve and get 1 point of intersection. Then if you have a curve and a line not meeting, it means we can't solve these two, so we shall use b squared minus 4ac less than 0. So we use the idea of discriminant still on intersections. So if they intersect twice, we get 2 points of intersection, meaning we can get two solutions that are distinct. If it is equal to 0, we get one solution that is repeated. And if they do not mean, it means we cannot solve. So we are going to answer this question. So they're saying find the values of k for which the line is a tangent. So you need to know if a line is a tangent, it means the discriminant we shall use should be of b squared minus 4ac equaling to 0. But remember, we use this discriminant on a quadratic graph. So since we are talking about intersection, the line and the curve intersecting at one point, we shall begin by solving simultaneously. So if I have y equaling to x plus k and another y equaling to x squared plus 5x plus 2, they are all equal to y, so I can equate them. So x squared plus 5x plus 2 is equal to x plus k. This is not quadratic. I take everything on the left hand side. So I have 5x minus x plus 2 minus k equaling to 0. I end up having x squared plus 4x plus 2 minus k equaling to 0. So this is something quadratic. So now when I reach at this point, I can bring in the idea of a discriminant. We bring in the idea of a discriminant after forming a quadratic expression. So when it comes to intersection of line and curves, we begin by solving simultaneously. If it was just a curve, then we first form something quadratic and right away apply the discriminant. But in intersections, we have to first solve simultaneously, form something quadratic, and then we can do that. So next, after bringing the idea of a discriminant, so b squared, we shall say 4 squared minus 4, a is 1, and the c is 2 minus k equaling to 0. So we shall have 16 minus 8 plus 4k equaling to 0. So this is going to be 8 equaling to negative 4k. I divide by negative 4, I divide by negative 4, and I get my k, which is negative 2. So it was one value of k. So find the value of k for which the line is a tangent. So for you to have this line as a tangent, it means that line must be x minus 2. So you begin by solving simultaneously because they are all equal to y, you equate them. If one is not equal to y, you first make one the subject and use substitution. So you equate them, form something quadratic. So after forming something quadratic, then you bring in the idea of a discriminant, b squared minus 4 then yeah, A, then the C, and it is important that you put in a bracket. So we shall have 16 minus 8, 4 minus 4 times negative k, you get plus 4k, then you can solve. So 16 minus 8, you get 8, into negative 4k, you divide both sides by negative 4, and you end up having your k as negative 2. Meaning when k, so if they had continued and asked us for that point of intersection, you would come and substitute here. In your quadratic equation, where there is k, you put a, you make your k to be negative 2, and then you end up solving that quadratic equation, and that quadratic equation that you solve should give you one solution.